Good afternoon, everyone, and welcome to today's webinar. We are going to dive into perhaps some new insights that you might not have thought of, realized, or even really considered as we look at the hail hazard today. This is a joint webinar between IBHS and ZestyAI, and we're going to take you inside some recent work that we've done really entitled Small Hail, Big Problems, and perhaps some insights that will help bridge some of those physical science and loss estimation gaps that you may have. This year is no stranger to large losses driven by severe convective storms. We are looking at perhaps a record-setting year when it comes to the amount of damage caused by severe convective storms here in 2023. Much of that this year is related to the hail hazard or hail peril. We did have some tornadoes this year early on in the season, but much of what we've seen this year has been driven by hail. It's been almost a nonstop peppering across the U.S. We had a tiny break there in the middle of, say, August or so, but things picked right back up a couple of weeks ago. We had an event go right through the Austin metropolitan area. So we're hoping today's discussion will open your eyes to kind of a hidden piece of hail damage that you may not have considered that could help fill some knowledge gaps for you. This was a joint project that really took both laboratory and field research that we did at IBHS and combined with the analytics work of folks at ZestyAI to bring kind of a new lens to hail. Just a little bit about myself. I'm Giammanco. I'm the managing director for research here at IBHS, and I'll get to play host for today's webinar. For those of you out there, the several hundred of you here who have registered for this webinar, you may know me from the hail space. I live and breathe this peril. I've been involved in leading the IBHS annual hail field program since 2012. I've been with IBHS now for almost 13 years. And also was on the team that developed the IBHS hail impact test protocol and pioneered the use of 3D laser scanning to create great representations of hailstones that we use in the lab. So a couple of housekeeping things today before I introduce our wonderful speakers today who actually conducted the work that you're going to hear about today. We will also have some poll questions throughout the webinar. We'll get to our first one here in a minute. But that takes me to introducing today's speakers. As I mentioned, I'm Ian Giammanco from IBHS. I'll introduce my colleague from IBHS, Brenna Meisenzahl. Brenna is a research meteorologist who specializes in multi-peril work at IBHS. She has a background, of course, in atmospheric science, but also has a master's in data science from the University of Notre Dame. Brenna has participated with us here in the field at IBHS, as well as guiding the novel laboratory testing you're going to hear about today. Next up, we have Bryn Ronalds. Bryn is a senior data scientist at ZestyAI. Her background is also atmospheric science and climate science. She has a PhD from Colorado State, again, focusing on the impacts of climate change. So Bryn really led the analytics effort here to try to bridge how we take field observations, laboratory results into that space. And then lastly, but not least, Stephanie Kuczynski from ZestyAI. Stephanie is a risk analytics manager at ZestyAI and has a wealth of experience throughout her career in the insurance industry. Prior to her role at Zesty, she was at companies such as Progressive, ASI, American Integrity, and the Hartford. So she has a wealth of industry experience. And that's where Stephanie's going to take us, is looking at the industry applications of the work we've done. So with that, we will dive into really our very first poll question of today's show. We're going to ask a question here. How confident are you in your ability to assess hail risk, or your current ability to assess hail risk and mitigation strategies for this particular hazard? The poll options are up there on the screen. We'll give everyone a few moments to select the answer that fits where you see your work and maybe perhaps your company's strategy with regard to what I would call is a not so secondary peril. I used to joke probably years ago, hail was the hazard that gets no respect. Well, you know, I'm too old for the Rodney Dangerfield references. I'm talking to a younger audience who has no earthly idea what I'm talking about. But I would say today, because of the damage we see day to day and over the course of a year, this is not a peril that gets no respect. This is one that we have to take very seriously, from understand how do we manage risk, how do we manage exposure, and also what are the mitigation potential related to this particular hazard. So there's our answers right there. Actually, nice kind of Gaussian distribution. We'll throw out some data terms there. With most of you going with the somewhat confident, I think that's probably pretty good. And then there's a group in there, 40% not very confident. So that's our middle of the road ground. And I would say that's probably a place where a lot of us kind of feel that this particular peril may actually be. But we hope to shed some light on perhaps a kind of a hidden piece. I mentioned that right off the top, a hidden piece of hail damage that comes with perhaps hail events that we don't readily think about. We're all accustomed to seeing pictures of large hail impacts on various building materials through social media, the media, however. But there's a piece of this. Most hailstorms don't actually produce those giant behemoth hailstones. And a lot of times, the smaller the hail that's falling, the larger the concentrations. And that led to ultimately the questions of how do we tackle this problem? How do we look at the effects of all the different modes of damage and flavors of hailstorms? So that's kind of where we're going to start. This project really began with observations that IBHS we've made in the field, trying to understand what are the concentrations of hail. What are these high concentration snowplow kind of hail events? What do they look like? And then counter that, what do they do to our building materials? And then we bring in the piece from ZestyAI about how do we take that information and turn it in something that could be used across the industry. So there's where this really became a joint effort to bridge field laboratory and analytics to really get to some new answers. So that's kind of where we're at. And we're gonna summarize some of the kind of key findings here. I'm gonna bring in our first speaker here soon. We're gonna start with understanding, where we're headed. We know losses are growing. We also know that the area where the biggest hail in hail events is often kind of that tiny area of the hail swath. And hail events that have smaller sizes often have higher concentrations, especially in areas like the Front Range of the Rockies. So that's where we're headed. And I'm going to go ahead and bring in our first speaker, Brenna Meisenzahl, to kind of summarize a little bit of our initial field results and a bit of the laboratory results. We'll dive into the deep side of the pool here in a little bit, but I'm going to toss it over to Brenna, who's at the IBHS Research Center, to give us that very first kind of look at what we found when we started looking at this problem.
Hi, Ian. Thank you so much. As he mentioned, the hail hazard is a huge deal, and high concentrations of small hail really needs to get looked at. They are so much more common than your larger 2-inch stones or 3-inch stones. They may be seen in a small area in that storm where everywhere else is your small subsevere hail. And because of this, we need to understand the damage potential that these stones cause to your roof. How do they affect the roof itself, and what happens later down the line? So IBHS conducted a very mild study on this, just to kind of dig into those questions. And when I say mild study, we know, as Ian talked about, how rare those 2-inch stones are and how more we see the subsevere stones. We know that from past field deployments, we can see roughly 10,000 hailstones fall in a 1x1 square foot in about 20 minutes. So that's a lot. That's a lot more than what you'll see with your 2-inch stones. So when we did our test here at the lab, we did notice that it does shorten the lifespan. The subsevere hail impacts do shorten the lifespan of your roof. They make your roof more susceptible to damage, and they will cause visual damage that will likely lead to a claim later on. So how did we assess our damage? And I'll dive more into this later, but I'll bring it up briefly here. We use machine vision to handle that. There were pre-impact photos and post-impact photos that were overlaid with one another to assess that damage. And we get some quantitative data from that to analyze and get our area of granule loss that's compared to each product that we tested. And with that, I'll bring it back to Ian.
Yeah, thank you, Brenna. Just a little bit of that results. We were, as Brenna mentioned, we were shooting, a couple of hundred or so hailstones, and we realized through field observations, as Brenna mentioned, this was kind of mild compared to some cases that we actually now have observed. And you would be shocked to understand how much hail can fall, even in just a 1 square foot area. And there's been a modeling study that looked at a hypothetical scenario that one single supercell thunderstorm can produce more hailstones during its lifespan than there are trees on the planet. And that kind of shakes you a little bit, right? To understand that these storms can produce vast amounts of hail. And that's also a place, though, where we don't really know what it is about the environment that produces these snowplow kind of hail events versus ones that may produce lower concentrations of large hail, things like that. We're starting to gain some insights there. We also understand geographically where they're a little bit more common, like in the Front Range of the Rockies and the high plains. But we wanted at IBHS to take a look from the damage part of this, is what does this do in terms of damage on a roof, specifically asphalt shingles. We know that the asphalt shingles are our dominant roof cover here in North America. They're on over, somewhere around 3/4 of the roofs in the United States for residential construction, and they are the most vulnerable to hail. Our building materials, we simply just don't build with this particular hazard in mind, and now we see this spectrum of hail that's impacting our built environment. So that's kind of where we are. IBHS, way back when we started the hail research program, our goal was, one, to improve building material testing. Could we make a test that replicated natural hail through the material properties of the ice itself, the strength, the density, all of that? And we were successful in doing that, both collecting field measurements that would later play a role in the work we've done and I'm going to show here today, but also being able to do something that's repeatable. And we did that work, and we've been able to do a lot of material tests, look at shingle performance to 1.5, 2-inch hail using individual impacts, and then scoring kind of holistically a set of impacts through our impact test protocol. But this work took us down a different path, is much more about simulating the storm itself, as opposed to the individual impacts and then using our machine vision tools to score those. We wanted to see, hey, what's going on here with these kind of events? And how does it impact our industry? And what is it possible that this is some of the gap in terms of understanding the damage we see year after year from hail? So I'm going to toss it back to Brenna, who's going to take us out to the field, take us out to the lab, and give you an insight of how we do this kind of work as we start into the deeper dive into the combination of work between IBHS and ZestyAI here, looking at small hail, big problems. So Brenna, back to you, and give us a look at how this all comes together.
Yeah, thanks, Ian, again. So yeah, as Ian mentioned, I'm going to take you into the field, talk about our field deployments, and then how we bring that back to the lab and do our testing here. So again, as Ian mentioned, our field study started way back in 2012, and we needed to be able to replicate hailstones, realistic hailstones in our lab to test building materials. We needed to make a test that was repeatable, and to start off, the way we needed to do that was we needed physical measurements of hailstones. And at the time, there was a huge gap in data measurements, physical measurements of hailstone. There was no quantification for strength. So that's really the first step that we needed to tackle. And this timeline gives you an idea of our beginning goals and kind of where we've progressed to now. We've got a lot of those physical measurements in our database. We've added a couple of pieces of equipment over the years, our 3D laser scanner, which Ian mentioned in the beginning. We also have a fleet of impact astrometers that capture the impact of hailstones when they fall. That's how we were able to capture those 10,000 or so hailstones in 1 square foot within a 20-minute time span, was from those impact astrometers. And we've progressed now to trying to understand the environmental characteristics and the environmental controls on hail strength, because that's really important. As I mentioned, our impact astrometers, just to give you a little look to what they are, what they look like. They have a plate at the top. Underneath that plate is a sensor that detects every impact from a hailstone, and it is a voltage, which through some programming, we can connect that back to a kinetic energy and a size of stone that actually fell within a given time frame. One of the other aspects of the field deployment that we've added on this year too is bringing asphalt shingles into the field, not just impacting them at the lab, but bringing them out into the field and assessing the damage in real time and comparing the damage we see out in the field to what is seen in the lab, give it high concentrations of subsevere hail or those 2-inch hailstone impacts or anything larger. Again, bringing it back to the lab. This is our large hail machine, and this is how we create our ice stones here. This is all as a product of what we've done in the field, all the physical measurements we've taken, that compressive strength of stones, understanding the density differences. And you can see between the three, a natural hailstone, our lab generated hailstone here, and just regular ice, regular water. The densities are different. They clearly don't have the same core. They're not grown the same. So what we do back here at the lab is we actually infuse the water in our tanks with CO2, and it's diffused for a certain amount of time, depending on our so-called recipes that we use to make ice, whether it's 1.5 inch or 2-inch hailstone. And now that I talked about the field, we're going to get more into the experiment itself, our high concentration of subsevere hail. So a quick reference to our test matrix, kind of how we conducted this testing. We had two groups, an experimental and a controlled group. Our experimental group was naturally weathered for 1 year. Our controlled group was sat in storage for 1 year, wasn't touched. It was in a temperature controlled room. After that year passed, the products were brought into the lab. There were pre-images taken of these panels so that we can compare it to the post images after these products were impacted, and that's kind of where our machine vision came into play, at looking at the differences between the two, the differences between the two photos. That process was repeated one more time. So there was 1 more year of aging, 1 more round of hailstone impacts. After that second round, we had a third round of impacts that followed our IBHS test protocol, where we impacted the panels with 2-inch hailstones. And this was really to look at how the shingles behaved, how the damage was, or how the shingles were affected after being impacted with subsevere hailstones and then large stones, and then comparing them to panels that had only been impacted with large stones. And we'll see that those results in a couple slides here. So as I mentioned, we had our naturally weathered panels. We used 6 different products for this test. There was a twin of each product, so that we had 12 of each. That created our 2 groups. And we used both conventional non-impact rated shingles as well as impact rated shingles, because you would assume impact rated shingles, they're going to perform better. We really wanted to look into that in this case as well. Impacting, as I mentioned, this was subsevere hail, so your subsevere is anything 1 inch and below. So we used 500 hailstones, a mild case study, 500 hailstones. 200 of those were roughly 1 inch in size. 300 of those were 3/4 of an inch in size. Taking a look at some of the machine vision processes that we went through. So your image on the right shows you the pre-processing of the photos, where the algorithm is trying to align the 2 images, and those checkered boards you see are just used as reference points for the program. And then your output of this program is shown on the right, a little bit of a darkened image, but those areas of white or reddish pixels, those are the differences between the 2 images. Those are the granule loss. Another program that we use, another form of analysis that we used, is called a nemesis analysis. This was done after the 2-inch hailstone impacts. It was not done after each and every round. This is because the shingles need to be cut out in order to use nemesis. And each shingle is has individual photos taken of it, roughly about 15, so that the program can see all sides of the impact and all sides of the shingle. And nemesis allows us to get depths of dents, heights of ridges, and it does do some granule loss detection as well, and can categorize between individual and patch granule loss. So So let's look a little bit at some of our results. This image I'm showing you now, this is a good performer. This was, I believe, our best performing product after going through all 3 rounds of testing. It's kind of hard to see some of those granules that were lost. I can pick it up a little bit if you look closely at the left-hand image. And of course, the machine vision did pick up some granule loss. I want to note that this is a naturally weathered product. This is also an impact rated product. Moving on to our next example. Again, this is very, very visual in the damage. This was our worst performing product. Clearly visible to the naked eye where the hailstones impacted this panel and all the granules that were lost, given that right-hand image from the image processing. This again was a naturally weathered hailstone. However, this was an impact rated shingle, even though it was our worst performer. So let's dig more into like the key findings and key takeaways that we really want to make sure we bring up to you guys. So as I mentioned, the 2 panels I just showed you were both impact resistant panels. This damage is not limited to just conventional products. It's not just limited to your non-impact rated shingles. You will see this type of damage on your impact rated shingles. It's seen through the asphalt shingle spectrum, and panels like, or shingle products like the worst performer that I just showed you, something like that is absolutely going to cause a insurance claim. And mind you, this was a very mild study with roughly 1,000 or more hailstones. Imagine what that panel could look like if you had 10,000 hailstones. Just a little snippet of that paper that both IBHS and Zesty did with each other. These are average areas for each round of impacting that we did, but it's for a single hailstone. So we have our baseline that was just, those panels were just impacted with 2-inch hailstones. They did not experience any subsevere impacts. About 20 millimeters squared area of granule loss. Let's take a look at that controlled. There's about 3 times more granule loss when it's been impacted prior with subsevere hail. Again, this is our control group. This was stored for a year. Now let's move on to our naturally weathered panels. There is 10 times more damage on average that we've seen with naturally weathered hailstones for a year, or naturally weathered products for a year or 2. And they've been impacted with subsevere hail. We get that almost 10 times the amount of damage from just a newer product that's only seen a 2-inch impact. Really some key takeaways. I'm going to repeat this, but those smaller subsevere hailstones can cause nearly 30% of the granule loss seen in a 2-inch stone, as I just showed on the table before. And in terms of only asphalt shingle products, they're 10 times, or roughly 10 times more susceptible to damage after natural weathering and being impacted with subsevere hailstones. You know, those granules that are in your roof, they're super important. They are there to protect the asphalt. That is their job. When the roof sees a hailstorm and those granules get displaced, your asphalt is exposed. It's exposed to UV, which makes your roof and your shingles more brittle. This goes along with our hypothesis that the shingles degrade over time, and it makes the shingles more susceptible to damage when it's previously been impacted with subsevere hail. Again, these small hailstone events can reduce the roof's lifespan, make it more susceptible to future hail events, and exacerbate the natural aging of asphalt shingles. And with that, I'm going to pass it back off to Ian.
Yeah, thank you, Brenna. That showed us, just the results of this really novel experiment where we were looking at more what can a hailstorm do. So a couple things I want to add in here just for some context. Hail is a peril we don't observe very well. We have the severe criteria from the National Weather Service of 1 inch. We have to rely on really two ways of detecting and capturing our hail risk across the U.S. One, reports. So that's you and I, that's all of us, reports to the National Weather Service estimating the hail size that fell where we were, and it gets logged. There's certainly cases we have in our IBHS field catalog that there are no storm reports for, yet we know hail fell there from our observations, whether it be in situ with our disdrometers like Brenna showed, or us physically measuring hail. So that's an issue. And I know Bryn's going to show a plot that kind of highlights some hot spots in hail reports across the country that, look at the urban areas. There's people there, right? And then the other piece is weather radar. Weather radar has high false alarm rates, meaning that a lot of times it can tag hail where there was no hail at the ground. Sometimes the swaths are larger than actually what occurred in the field. So this presents a challenge to look at these events that wouldn't readily be logged in our severe events database. So that's one piece of this. So when they do happen, we actually think they're more frequent than we even know. So that there's kind of been this long community thought that we probably do underestimate the risk from smaller, just generic hailstorms like this, like we've just talked about. And the prevailing thought was, oh, they're not very damaging. They're not doing anything. Well, I think we've shown that that's probably not the case for sure, especially when you look at some of those poor performing products where you have mass amounts of granules. Let me back up. Rainfall can dislodge granules, but hail is really, really, really good at dislodging granules. I used to joke it's like scrubbing bubbles. Brenna knows this. Like if, back when I was in school, if I drove the field vehicles on a dirt road and I didn't want my professor to know that I did that, I'd go look for a little radar echo to go find these kind of hailstorms and just go drive through it because it washes your car really well. It doesn't cause any damage. But from a roof perspective, the scrubbing bubble effect is going on there. Now, these aren't the big dents and tears that's going to cause an immediate water concern, like we've seen in some of our laboratory work where we'd actually put a water head on top of a damaged shingle. But when that underlying asphalt gets exposed, Brenna very much proved that those materials simply become more brittle and they're more susceptible. So this is a balancing of what is a longer term damage process versus something short term like a very severe event where you have big dents and tears. So I want you to start to think about getting out of the paradigm of cosmetic versus functional damage itself, but it's a time span thing, much more about timing. And having to evaluate the return period or frequency of events that happen in a specific location when you're looking at your risk. So thank you, Brenna. That was wonderful to take our viewers inside the project piece that we did at IBHS, which was bringing field observations into the lab to simulate what could happen on a roof. Now, to get into the industry part, how do we take that and go do something with it in terms of understanding risk and the potential for loss and things like that? That's where our folks and friends at ZestyAI come in, specifically Bryn Ronalds, who really dove into this from the analytics space as a way to possibly fill a gap that we've seen in trying to get a better handle and better way to categorize, estimate, and really have some predictive power right around hail losses that we know, we're dealing with, billions, probably 40 billion close this year in this problem. So I'm going to toss it over to Bryn, who's going to dive now into the process in the analytics space of how do we take that information that we got from the field and the lab and then turn it into a piece that the industry can actually apply.
Thanks, Ian. So as Ian said, I'm going to be working off of Brenna's lab and field work and showcasing how we then use the same concept of small hail, but in a more data science oriented machine learning kind of way. And we're really trying to focus in and zoom in on these challenges of predicting hail claims, and especially hail claims in areas that we don't normally consider to be hail prone areas. And this is where these newer machine learning methods or predictive modeling can really help bridge that gap. And focusing in especially at property specific granularity. So at the property level, each property has its own characteristics that could increase or decrease its risk depending on the region it's in, but also property level. And kind of combining all of this, the machine learning aspect, understanding the property characteristics, understanding the climatology at play, can we really start to improve this intra-territory risk splitting? So what I'm showing here is a average annual hail frequency of hail events that produced 2-inch or above hailstones. And this is averaged out over 21 years. There aren't too many surprises here. We really see the hail belt or tornado alley or the plains, however you want to refer to it, pop out, as well as a level of urban bias. We don't see any 2-inch hail events really to the west of the Rockies, unsurprisingly, and we also don't get a very strong signal over in the Midwest and Southeast regions. And so there is a kind of a gap there. If you compare this climatology of 2-inch hail events to a climatology of hail events that are below 2 inches. So these are all the convective storms that produced hail, but didn't hit that 2-inch criteria. And now we have much larger coverage across CONUS, contiguous US. We do have hail events west of the Rockies, and we also start to see those signals in the Midwest and the Southeast really pop. And this is going to become important because if we overlay that 2-inch climatology, hail events with 2-inch stones, the climatology of that with hail claims, so real loss data in red, there is some lift in the areas we expect, the hail belt primarily. There's some hail events that produce 2-inch hail to the east of that, but not enough to warrant all of these claims, not enough to provide a significant lift. If we instead overlay these claims on a climatology, again, 21-year average annual hail frequency without any size thresholding, these are all hail events, all available hail reports. Now we start to get somewhere, especially again, the Midwest and the Southeast really pop and overlay well with where the claims are occurring, in addition to that hail belt tornado alley area, as well as the sporadic hail claims we do get west of the Rockies. This then is the basis of what we try to get at in the white paper and the basis of these simplified modeling experiments. So in the white paper, what we are comparing are two very different approaches to hail claims and hail risk. The first, what we kind of termed forensic approach or salient event approach, is this idea of claim verification. A hail claim comes in, was there a large enough hail event producing 2-inch or above hailstones leading up to the claim being made, in this case, the year prior? And we use that as a predictor in a model. And we give it the frequency of a big hail event in the year prior to a claim as an input, including non-claims. And then we see what the fraction of hail claims occurring in two different buckets, a below median and above median of the model output. This is our hail risk. So if we look at how many hail claims fell below the median of hail risk and how many hail claims fell above, we're only seeing about 10% lift. This isn't great. Obviously, this is a very simplified view of this approach, but it's still rather telling. We're missing information here. And in fact, when looking at the data, about 45% of the hail claims within the data set did not have one of these big significant hail events in the year prior to the event. Compare this instead to what we call the predictive susceptibility approach. So this is utilizing all hail sizes, and it's also utilizing the history. There are specific conditions and areas that have the right environmental factors to create the convective storms needed to produce hail. So we can really utilize and leverage that historical context to create these climatologies that I showed earlier. So this is the 21-year average annual hail frequency, no size threshold. So we don't care about the hail size. We want all available hail reports. And now that is the predictor in the model. And we compare again, below median hail risk to above median hail risk, how many hail claims fell in each of these two buckets. And now we're starting to get somewhere. So this is 580% lift. Again, this is highly idealized, but it gives you a really clear insight into the two approaches and how much leveraging you can get from historical context and small hail. So based off of this work and based off of what Brenna and IBHS found as well, we want to start to talk about improving the modeling approach or changing up how we view the approach depending on the use case. And in this case, I really want to compare it to more traditional approaches such as stochastic modeling. So what's key is stochastic modeling works really well on a portfolio management, like losses across a certain region, but it's not filling all the gaps and it's not getting the whole story. And here are some of the reasons why we suspect that might be the case. So again, hail of all sizes, we're really hammering home this point. The small hail matters. Brenna showed it leads to an accumulation of damage and degradation of the roof. And so when you think about stochastic modeling of hail events, the focus is on significant hail events. Again, using size thresholding to get those catastrophic perils. And we have shown and demonstrated, I think, through this work, and Brenna certainly has shown it in her results earlier, the small hail matters. And so including that and removing any size thresholding into your model inputs can provide a great deal of lift. Also looking more closely at property-specific characteristics. Instead of using a distribution of possible inputs about a property that are likely in given regions or client input information, we can also leverage computer vision models based off of aerial imagery to get as up-to-date and recent insights into a property that are more objective. There's also the interaction of climatology and those property characteristics, and this is really important. Again, stochastic modeling does this in terms of probabilistic functions and distributions, but if you look and switch over to more of the machine learning nonlinear model approach, these nonlinear models are getting at those relationships and that interaction explicitly, which is incredibly powerful because those relationships matter and can change a single property's hail risk depending on where it's located and certain property-specific characteristics. And finally, the use of real claims data. Again, there's not much difference here in terms of the data is available and we are all using it, but stochastic models are generally built on simulated and estimated loss data and then calibrated and verified on real claims to get your loss curves. But where is this? So when you're looking at machine learning predictive models, these are built, trained, and tested entirely on real claims and loss data from carriers. What this sort of looks like. So I've given kind of a rundown of the differences and kind of the idea of a change in approach. And this is going to be more of an idealized framework for what this modeling approach could look like. You have your inputs. Again, the climatology. We don't have to stop at just hail frequency. We can still look at hail size. We know that size matters. We know that 2-inch hailstones are going to cause more damage as long as we're still including that information about small hail. You can also incorporate other environmental factors. Because the model leverages nonlinear interactions, there's a lot of other factors that go into play in creating the right environment for these convective storms, and all of these can play a role within the model to learn what level of risk each area has. Add to that the property-specific characteristics. Again, leveraging those computer vision models to get as up-to-date as possible information on a property, on a roof condition, size, shape, etc. And these play off each other within the model. And the industry loss data. This is where those extensive loss databases, multiple carriers over multiple years can be leveraged to create a profile of here's where claims occur, here's areas that we think are high hail risk, but we didn't get a claim, and leveraging those non-claims as well to start to get at, okay, which property is at risk and what level of risk are we looking at? This then goes into the model. In this case, an idealized example of a gradient boosted model. It's essentially an ensemble of decision trees, and each of those decision trees is saying, hey, I have this climatology, I have this feature, I have this property specific characteristic. Combine these specific values gives this answer versus change one of these values. Oh, we got this answer instead. And it learns over a very large training set and can start to get at these interactions and relationships. The output of these models totally depends on what you're targeting. So you could be targeting the relative risk of a property filing a claim. This is claim frequency. So I have a specific property in my portfolio. What is the likelihood that they are going to file a hail claim in the future? And then claim severity. Once they have filed a claim, or if they file a claim, what size is that claim? What is the loss value amount that's going to be on this specific property? And because of the way that these nonlinear models work, picking out the feature interactions and relationships, you can also leverage this explainability and these relationships to give you your top reasons. Why did I get this score? Is there anything in the reasons, property specific, especially, that can help mitigate your hail risk? And combine this approach, especially the nonlinear interactions, the climatology, and the industry loss data is so key for this because you can really start to improve that intra-territory risk splitting. And with that, I'm going to hand it back off to Ian.
Thanks, Bryn. That was a great explanation of how to take that kind of information from the laboratory environment and go apply it. And for me, it was more fascinating. We've had had an interest in the Southeast hail events in the U.S. that are, one, hard to forecast, and two, not necessarily observed very well. But we start to see that signal shake out, even in a hazard where we're just looking at reports. We can still gain information off of that. Now, on the mitigation potential, I'll throw some comments out there. One of the things that our role at IBHS is can we get manufacturers to raise the bar? We clearly see that this granule loss is a problem. We can fill in this gap with claims experience. We know that this is happening. So how do we get roofing manufacturers, mostly the asphalt shingle industry, to raise the bar and solve the granule loss problem, which we also know is the piece when you look at the aging of shingles starts almost immediately. Now, the dents and tears for big hail, at least in our work through 5 years, don't change appreciably, but the granule loss, that problem starts almost immediately. And then there's a wind factor that comes into play once you hit that 10-year mark. So this was a great chance to take a look at how you turn laboratory fieldwork into an assessment of hail risk and what to do about it and how to fill some of those loss knowledge gaps. So we're going to keep going down that thread. I'm going to bring in Stephanie now, who's going to kind of push this even further into the work that they're doing at ZestyAI. So for now, I'm going to send it over to Stephanie, who'll kind of keep taking us down this line and the work that's been going on at ZestyAI.
Awesome. Thank you, Ian. So just to kind of bring everything together, so we've heard from Brenna at IBHS why all different types of hailstones matter, that degradation on the roof. We've heard from Bryn how we can gather information about the climatology as well as property specific characteristics and how a machine learning model can marry all of those together. But what do I do with that information? How does that apply to me as a carrier? So this is kind of where the industry sits right now. Kind of a narrow focus on hail, looking at the impact of 2-inch plus hail mostly. Those are the dramatic events. That's what usually makes it onto the news because there's golf balls falling out of the sky and it leaves dents on things. It's very dramatic. It's what we look at. But as we've noted here, everything kind of matters. Small hail matters as well. So we need to use more. There's gaps, there's information that's missing that's available to us. We just need to make use of it. And how are we going to do that? So we're going to look at everything that really does matter for hail risk itself. So we're going to include climatology of all hail sizes. We're going to look at that accumulated damage to roofing structures, which is somewhere where ZestyAI really starts to shine, is looking at that accumulated damage and that interaction of roof anatomy and climatology that the gradient boosted models does provide for you in that nonlinear fashion that is very powerful. So I've talked about properties specific characteristics a bit. This is a visual representation of what ZestyAI is able to do with aerial imagery. We're able to build a digital twin up from the ground for every property in the United States. This gives us a whole host of data points that are available for us to use. We're able to look very detailed at the roofing anatomy of a structure, gather the actual roofing material. What's the condition that it's in? What's the slope of the roof? Valleys, pitches, all different things that really speak to the susceptibility of the structure itself. And we're able to marry that up with climatology data as well to get down to a very good granular view of risk of the property itself. So what are you going to do if you have this whole picture? So we've already gone over the ZestyAI and IBHS research in detail, but just to reiterate, 99% of hailstones are less than 2 inches. So all that subsevere hail that Brenna talked about earlier, we're going to gather that up and we're going to use that information. What do we see from there? Bryn showed 58x segmentation power when we look at the entire picture as opposed to just focusing on those dramatic events that are 2 inches and above. So think of what you can do with that kind of segmentation power. We combine all of that together, the field research and the billions of data points, and we have built 2 predictive models. So this is looking more predictive as opposed to trying to chase where the most recent hailstorm was. Maybe I'm going to make some sort of adjustments there. I'm going to take a more predictive approach. We have Z-hail claim frequency and we have a severity score. So just briefly touching on these, the frequency score is going to be indicative of the annualized probability of a property being involved in a future hail claim. So within a policy term, what's the chance that this risk will actually be filing a hail claim? Once you know that the claim has been filed, we move on to severity. That's going to be indicative of the relative hail claim size. So is it going to be a smaller claim? Will it be a larger claim? That's what severity will kind of get you that view of for the property. Today, we're going to focus on frequency itself, and we'll touch into this just a little bit moving forward. So what are some of the actions that I'm actually able to take with the frequency and severity scores that Zesty has? Working with lots of different carriers, this is typically what we'll see people doing? These are ways that you're able to control loss costs. These are actions that you're able to take to reduce volatility on your book. Just basically help save money from the hail peril, how to accurately rate, how to accurately assign underwriting endorsements to risks. So we have kind of the typical ease of implementation. So those underwriting actions, loss cost control that you can put onto your book of business at this point in time. So ACV endorsements, reduce how much you're paying on that roof. Cosmetic damage endorsements, roof replacement schedules that look at the actual property itself as opposed to a broader territory approach. Elevating or mandating those wind hail deductibles. So this really gets you to be more advantageous to the properties that matter, so they don't have to have the 5% deductible. You're more appealing to them if you don't have to mandate a deductible over a zip code, over a state perhaps. Really gets you down to that very granular level of risk. New business risk selection. So if you know something's coming through the door and there is a large chance that it will be filing a hail claim in the coming year, maybe that's not necessarily something that I want to actually let onto my book. Non-renewing policies with the outsized risk of hail claims. So this is, you have a legacy portfolio. I'm seeing outsized loss ratios. I'm going to take a look at my book, see who is in that very risky category, and potentially non-renew them. Maybe I'll do some of the endorsements above, that's possible, but maybe I just don't want them at all, and I'm going to get that off my book. Managing concentration to control the volatility on your portfolio. Look at those pockets, see how concentrated they are with those high risk policies. Kind of spread that, thin your risk out so that you're not just getting hammered by events that go by. You have the more desirable properties in an area, so when a hailstorm does roll through, you're not getting hit with all of those claims. And finally, we have that apply more accurate hail peril rating at the property level. This just makes you so much more competitive where you want to be and non-competitive where you don't want to be. So that's just a great way to shift business back out into the market that you don't want and attract the business that you do want, because you have that great segmentation power from Z Hail, and you're able to apply that into rating. So looking at frequency across all states, we can see here 96,000 random properties on the left by their frequency score. Most of them are falling into that low or very low category. There's a lot of desirable business that's out there. You're not just going to cut everything off. But you can kind of see that it does taper down. There's some that fall into that high and very high category. On the left or on the right, you're able to see the annualized probability of hail claims across all states. So when you're in that very low category, you have a very low chance of a hail claim occurring, 0.01%. Once you move across the bars, you can see how steep that gets. You could put this into your rating structure and have a very steep curve for your hail rating peril. Once you get up to the very high category, you see an 11.9% chance of a hail claim occurring. That's huge. That's definitely information that I'd want to know on renewals. That's something I want to know on quote, so that I'm able to take accurate action on that policy. Taking things a little bit further, this is a client case study, came to us to look at Z Hail. So we looked at some of the key states for them: Texas, North Carolina, Colorado. The line that you see is the hail peril loss ratio itself across Z hail claim frequency scores, and the bars represent the distribution of the policies that were within the sample. And you see incredible lift across all of the buckets. So this is definitely information that I want to know. And I can also get a good view into how my book is sitting right now. So if I'm looking at Colorado, oh my goodness, I have so many over in the very high and high category. But there is good business that's available. I'm going to take measures to shift from those 9s and 10s over to those 1, 2, 3s, and 4s. That's what I want to have on my book of business. I can see the loss ratios better. This is just proving it out, how powerful this can actually be for you. And this is just the applicability of having the climatology married up with those property-specific characteristics. Similarly for Texas, you can see that there's a decent amount of properties in that high and very high category. Loss ratios off the charts. Again, this is somewhere that I can take action to help move my book of business to something that is much more desirable. getting even more granular with this client case study. So we looked specifically at a zip code for them within Texas. This is on the outskirts of Houston. The entire industry view of this zip code itself is going to put you in a moderately high overall look. So this is maybe something where previously you would just mandate wind hail deductibles at 2%, 5%. Everyone's going to be on ACV roof. That kind of blanket approach that we were taking before. But you can see how granular you're able to get when you take all of those property specific characteristics into account and the kind of risk splitting power that you get. So there is a good amount of desirable business in here. When looking at that loss ratio, you can see that it is performing very well and being able to pick out the properties with a better risk profile, even at the zip code level. So these are potentially properties that are exposed to the same events. So this just goes to show how powerful the property specific characteristics can be, because these people are all probably experiencing the same kind of weather events. But marrying that up with the actual structure itself really does give you a good view of the hail risk itself. And with that, I will pass back to Ian.
All right, thank you, Stephanie. So we've ran through all the pieces and parts of this piece of work, as well as some of the work that ZestyAI has done internally to turn this into an application, which is at IBHS, this is what we want from, to be honest, all of our members, is taking the science that we use and finding a way to apply it. So one, well done. And I want to thank both Bryn, Stephanie, and Brenna, who are now all back with us as we look toward questions. So I think, I want to kind of sum up things. It's pretty clear that small hail and high concentrations can cause visual granule loss on asphalt shingle roofs. That is pretty much a fact. That will also make that roof more susceptible to the next hailstorm, especially if it's one of those largers. And I should point out, in our testing, most new asphalt shingle roofs should be able to withstand up to 1.5 inches hail. Once you get to 2 inches, that's when things start to scatter about, and then the age effects take hold. So that's that piece. But by taking that and then using it to fill the gap in our knowledge of hail and loss predictions, it actually all starts to come together. And this is something, as somebody who's been looking at hail for the better part of a decade now, to see that kind of start to complete the picture of things we sort of thought about over the last 10 years or so has been one, very interesting to see, and then see it turned into something that could become a usable piece of information. So let's hop into the question and answer side. We'll have some questions relayed to us. I'll start right off the top. This one's going to be for Bryn and Stephanie. First off, is there any guidance on how to communicate a hail risk to the insured? So this is taking it from all the work we've done and getting it into the policy holder or you all of our hands as to what to do about hail.
Absolutely. So I think Bryn kind of mentioned it in her presentation that you're able to pick out those top modifiers when you're using a machine learning model. So what we're able to do with what we have built, you're able to get back the top modifiers for why you're getting that hail risk score. So you're able to easily communicate to the insured, you're easily able to communicate to the agent exactly why you are being considered a higher risk. It makes things very transparent. It's very easy to use, and just takes away that kind of black box that has been the way things were.
All right, thank you. I've got one that I can handle. It's on the cosmetic versus functional damage side of the house. I think as an industry, we've had this, right? We all know that this is kind of how we've operated, and this has shown up across the board in how we look at not just hail, the wind element too. For asphalt shingles, the concept of cosmetic damage, as opposed to something that happens to that shingle that doesn't change it at all, I think we have got to get out of, and folks are going to have to figure out how to use that information. Brenna very clearly showed what's going on in these kind of cases. You're going to have to marry that with your hail risk, but also the element of wind as well. This is going to be a geographic way folks are going to have to start looking at this. What is the return interval of all types of hail? And we also know, I'm going to bring in some other IBHS research that we've shown that on the wind side, the vulnerability rockets up after that 7 to 10 year time frame. So this is pieces of information that are going to have to get put together to figure out how to work our way into a better place. Asphalt shingles is they are the cheapest roof cover material we pretty much have in the major market today, but they are actually one of the most complex from a building material system. And it's that complexity that has really introduced all these problems that we're seeing now manifesting itself into just skyrocketing loss numbers. So that one, that's the piece I can comment on and continue to do that. Let's see, let me kind of work our way through some of the questions here. On a question for Stephanie and Bryn on the Z hail side. Has it been successfully used to support separate hail rate factors in admitted markets?
Z Hail is a newer product to the market, but we have had a lot of great traction with Z Fire. We expect the same for Z Hail. We have a dedicated team that works specifically with regulators to make sure that the utility is there. You need to be able to file with this, but the traction that we really get with our AI model comes from that kind of visibility that we mentioned before. It's very easy to explain. It's very easy to understand. So it will be very, when it comes time to file, we have a team to support you, but also just we have great traction already, a great record, and I see the same for Z Hail.
Looking to see if we've got any more questions coming in through our chat function. We've got a couple of minutes left. I think we've got another one. Here's a question for Brenna. I think Brenna and I can tag team this one. How do two impact rated products perform so drastically different when they're subject to the same similar laboratory testing and labeled as such? I can hop on my soapbox over here in a second, but I'll let Brenna take this one to start.
Yeah, that was pretty crazy. And as you would assume, you think your IR products are gonna not look like how that one did, and was not going to be our worst performer, but unfortunately for this testing, it was. And we noticed that quite a bit. Like there's a huge variability in batch to batch in the damage and how they compare to one another. We noticed that in just any project that we're testing here at our lab, we notice some batch to batch variability. And that's the whole reason why, not the whole reason, but that is a reason why we do what we do, is because we don't understand why there's a difference, why there's such a big variability. And each shingle manufacturer uses its own different products per se. So I know there's different types of sealants that they could use, for example. Ian, I don't know if you want to add any more to that.
Yeah, I mean, I'll rewind the clock. This is why the IBHS shingle ratings exist, is to provide a relative performance across all impact rated products. They don't all perform the same. And especially when you get them off of through the distribution chains that the IBHS test program does. They might be labeled class 4 through the UL 2218 program. But if you just go look at the history of our shingle ratings, there is absolutely a spread. And this is just testing on the 2-inch side. The granule loss variance is even larger. And we see that. Now, wind is the area where we just don't have a good test to develop this relativities. And that's that's my soapbox for hail and testing, but that's a big reason why the IBHS shingle ratings exist. Very last we got one last question that's come in. This will be our last one. We've got about a minute to go. On the ZestyAI side, sources and resolution for aerial imagery that you guys use in your product development.
Right. So we use multiple imagery sources. Multiple planes will be flying over the United States. We have coverage for the entire contiguous United States to give us the most recency in imagery. But overall, we don't fly any planes ourselves. We do gather it from other sources. Yeah, I think that pretty much sums it up.
All right. Thank you, Stephanie. And first of all, I want to thank our speakers, Stephanie, Bryn, Brenna. It's been a wonderful ride to do this work together with ZestyAI, building across some of the work that we've done at IBHS. These are the things that we want to do. We want to do this with our members, and I want to thank the ZestyAI team for also allowing me to play host for this webinar as well. And for the several hundred of you that were logged in for this webinar, we thank you. We know this is a topic that's on the top of mind, especially as we come in toward the end of a record-setting severe convective storms year in 2023. So on behalf of IBHS and ZestyAI, we want to thank you for attending today's webinar, and we hope to see you on a future broadcast down the road. So for everybody on this one, thanks and have a great rest of your day.